Oh well. Alright, so we're going to focus on solving one-step inequalities today. So solving, graphing, and checking one-step inequalities today. We are going to focus mainly or only on addition and subtraction today and tomorrow. Then Monday and Tuesday we're going to focus on multiplication and division. And then we're going to quiz next Thursday. Okay, so Thursday or Friday will be our quiz. That'll be our last grade for the grading period. Yes, I have your other tests done, so hopefully today we'll get those back. I'll get those back to you and pass those back to you by the end of the class period. So, these first five, okay, all we're asking is you to write an inequality to represent the situation. The greatest weight that a forklift can raise is 2,500 pounds. So what symbol should I use if the greatest weight is 2,500 pounds? Zach?
X is less than or equal to 2,500.
Very good.
I was just going to say it though.
Good. Less than or equal to 2,500. Now, the greatest weight, that means the highest value. And then anything lower, the forklift can lift. The speed limit is 55 miles per hour. Craig?
Well, X is less than or equal to 55. I know all these answers, but I can't wait until I raise my hand. I just say the wrong thing.
Oh, yeah. A truck can tow a maximum of 7,700 pounds. Tucker?
X is less than or equal to 7,700 pounds.
They're all less than or equal
Good.
to.
You must be at least 48 inches tall to ride the roller coaster.
X is equal, less than or equal to.
At least 48 inches.
Oh, at least.
So,
Greater or equal to.
very good. Greater than or equal to 48 inches tall.
I'm so
That's
bad.
okay. All right, you can save up to $50 on DVD players this week. Up to $50. Zach?
X is less than or equal to 50.
Good. Excellent job, guys.
They're all except one.
Yep,
less
all
than
except
or
one.
equal
So again, our focus is right. Or we were writing. You were able to graph, and now we're going to solve. Okay. So our first problem is x plus 4 is less than 5. Now, if this was an equation, what is the first thing we would do?
Backwards T.
Okay, upside down t. Very good. So I do my upside down t. It doesn't change. You're still going to do your upside down t.
And then you would subtract 4.
Now, x is being added by 4. So it's the inverse of adding 4,
Subtract
subtracting 4. So I'm going to subtract 4 from the left. And whatever I do to the left, I always have to do to the
4. Right.
right.
Oh, but
Okay.
it's a bit confusing.
Ooh, wait a minute. Something right, hold up. I'm confused why you're subtracting 4 from 5.
Well, because 4 is being added on the left side.
Yeah,
So I subtract it to get to 0. And then whatever I do to the left, I also do to the
Right.
right. Just like an equation. We did this with equations.
Yeah.
Subtract 4 here. Subtract 4 here. It's the same exact thing. Our symbol is just different.
I have a question though.
Yes, dear?
Because how the sign is less than, wouldn't the value of x have to equal 0 then? Because when you subtract 5 by 4, you get 1. Then 1 plus 4 is 5, and we don't have an equal to underneath the less than sign.
Okay, so we'll talk about that. Good question. All right, so 4 minus 4
It's 0.
is 0. So we're left with x. Our symbol comes down. And then 5 minus 4 is 1. So our solution is x is greater than 1. Or sorry, x is less than 1.
Oh.
So let's look at our graph. X is less than 1. Where does our graph start?
At x. I mean at
0.
Nope.
1.
Our graph starts at 1. What kind of circle are you going to put at 1? An open circle or a closed circle?
Close.
Everyone show me. Open
Open.
or closed? Okay. We're going to have an open circle. Okay? So open circle at 1. Now we want x to be values that are less than 1.
So you have to take it
So our arrow is going to point to the
left.
left.
There it is.
Now, yes, Zach.
So like how it says that x is less than 1, would you always put it like how you have on the number line, so in this way, would you always put it the opposite way of what the sign says?
Not always. Okay? It's a good trick, tool to use. Okay? To just go like this, and that's the way your arrow points. That's a good trick to use, but we're going to look at a situation where that might not work. Oh, jeez. Okay, so Tucker said, well, but if I put 1 in and when I check my answer, it's not going to work. Tucker's exactly right. Because if, when I check my answer, oops. If I put 1 in, is 5 greater than or less than 5?
No.
No. Okay? So 1 is not a solution, but all these values that are less than 1 are solutions. So someone give me a value that's less than 1.
-2.
Negative 2.
-7.
Okay? So if I put in negative 2 for x, is that my solution set?
Yeah.
Absolutely. Negative 2 plus 4. Different signs, so I subtract. 4 minus 2 is 2 less than 5. Yeah. So when you're checking, pick a number in the solution set. It can be any number. You could have picked 0. You could have picked negative 7. I could pick negative 435. Do I want to work with those numbers? No. But I could. Because all of those values. An inequality has thousands and millions and cajillions and an infinite number of solutions. Those solutions just can't be 1 or anything greater than 1.
They can't be greater than 1.
Nope. If I were to put something greater than 1, so if I were to put 6, is that true? No. Okay, so those values here don't work. Okay, 1 and anything greater than 1 doesn't work.
Can you do 1?
Can I do 1? Is that true?
No.
Is 5 less than 5? Nope. So I can't use 1.
Does it take a look at
Okay. What, honey?
can you not use 1 just for like this?
Yeah, just for this particular problem, because we have an open circle at 1.
Oh, so if you have a closed circle.
If we have a closed circle, absolutely we could use it. Good questions. Okay, let's look at our next one. Number 7, which is just the next one. I have it on a different page. Yours is just the next one. All right, m plus 8 is greater than or equal to 12. M plus 8 is greater than or equal to 12. So what's our first step when we're solving anything? Upside down t, very good. Or backwards t, whatever you want to call it. M is being added by 8. So what's the inverse of adding 8? Subtracting 8. So I subtract 8 from left and the right. Okay. Again, that's showing balancing. Okay, whatever I do to the left side, I do to the right side. 8 minus 8, that's our 0 pair. So I'm left with M is greater than or equal to
4.
Good. Where does our graph start? At 4. Very good. What kind of circle? Open circle or closed circle? Closed. Very good. So we have a closed circle at 4. Okay. M is greater than or equal to 4. So I want values that are greater than or equal to 4. So which way am I going to go? Am I going to go to the left or am I going to go to the right? I'm going to go to the right. Very good. What values can I use to check my answer? Danica? 4 and above. Very good. I can use 4. I can use 5, 6, 7, 8, 9, a million. I can use any of those values to check my answer. Okay? So what I want you to do right now is I want you to check your answer with any value that is 4 or greater. So check your answer with any value that is 4 or greater. The solution is like M is greater than or equal to 4.
Oh.
Three values. What value did you use?
7.
7,
5,
5,
4,
9,
6.
6. When you solved, when you plugged that value in, did you get a true statement?
Yes.
Yes.
Okay. Is mine going to work?
Yes.
Yeah.
True statement?
Yes.
Yeah. So my solution is M is greater than or equal to 4. Now looking at number 8, what's different?
Signs, it's just flip-flops.
Okay, there's a negative.
Oh, negative 11 is less than.
Okay, there's a y as our variable instead of an x.
The sign is before the second
Variable.
variable.
Okay, so our problem is flip-flopped. right? We're used to having our variable on the left-hand side and our constant on the right-hand side,
So,
okay? Or our variable expression here, okay? We could rewrite it, okay? But I want you to notice what I do when I rewrite it.
you hold different problem.
What happened?
You flip-flop the sign.
Okay? My sign flipped,
Which is.
okay? Now, a good habit to get into is to always read the variable expression first. So y plus 5 is greater than negative 11. So when I rewrite it, y plus 5 is greater than negative 11. My problem has to stay the same. The integrity of the problem has to stay the same. We cannot change the problem at all. Yes, Zach?
How come you can't flip it because you're still getting that, y plus 5 is still greater than negative 11?
Can you say that one more time, honey?
How come you can't flip it because it's still saying that y plus 5 is greater than negative 11?
If I just did this, is that the same thing?
No.
No, because I'm saying that this is less than 11. Okay, so but this is actually greater than negative 11. So I need to make sure that I keep the problem, keep the integrity of the problem. Okay, now, if I did not rewrite it, okay, I'd still do my upside down t, right? Y is being added by 5. So what's the inverse of adding 5?
Subtract it.
So I'd subtract 5 from right, subtract 5 from left. Five minus 5,
Is zero, 0,
that's my 0.
and then negative 11 minus 5 is negative 16.
Okay, same signs, so we add. Now this is the case where we can't just follow that arrow trick. We read our variable first. Y is greater than negative 16. So our graph starts at negative 16
And then works right.
with an open circle, and I want values that are greater than negative
So you
16.
have to work right.
So our arrow would be to the right.
Okay.
So our arrow trick doesn't work for this one.
Because if you would just use that, then you would be going left. Which is
Yep. If I use the arrow trick, my arrow would point to the right and my problem would be incorrect. So that's why it's important to actually read the problem and not just rely on tricks, right? I'm all for tricks. I mean, if I can have a shortcut to something, heck yeah, I'm going to use a shortcut, right? But I have to understand why that shortcut works and when, and I can use it and when I can't use it. Okay? So I want values that are greater than negative 16. Okay? So I'm not going to lie. I'm not going to use negative 15. I'm going to use 0. Why am I going to use 0?
Because it gets you back to a positive number.
Well, not necessarily. It does, but not necessarily. Why am I going to use 0? What's the benefit of using 0?
You know, instead of
It's the same value.
It's easy, right? Okay? And again, life is tough enough. Use things that are easy. So if I can use 0 when I'm checking my answer, heck yeah, I'm going to use 0. So if I rewrite this, true?
Very true.
Very true. Okay, negative 11 is less than 5. I'd rather have $5 in my pocket than owe my sister $11. Dear God, I've never heard the end of it, right? Those of you who have siblings who have borrowed money, you get it, right? Okay.
I've actually never been. Yeah, my brother takes money from me and never gives it back.
All right, so here's something I do want you to look at. Now, let's say, don't write this down, I just put your pencils down. Okay? Let's say I followed my trick. And I went this way. Okay? Right? Oh, my arrow's pointing to the left, so I need to write my arrow to the left. When I go to check my answer, maybe I'll use negative 17, right?
It'll work.
Okay, so negative 11 is less than. Different signs, so I subtract. So I get negative 12. Negative 11 is less than negative 12. Is that true?
No, because negative 11 is.
Okay, let's look at where negative 11 is, and then negative 12. The further I get from 0, the lower my number.
Which just sounds weird.
Okay, which sounds weird, right?
Because when you think of a larger number, you think of the value of it.
You're right.
We're going negative, which is that the subtraction sign makes it 0.
Right. But that's why number line is a great thing, right? Would you rather have negative $11 or negative $12? You'd rather have negative $11 because you're closer to being in the black, right? So that's why checking your answers is a huge benefit. I know it takes time. I know it seems tedious. But if you have the ability to check your answer, you'll never get a problem wrong. The majority of you checked your answers on the assessment and you got none wrong. Okay. My online kids, no way. Okay? So there's a difference. Okay? Checking your answers, taking the time to check your answers. I only give you 5 problems on a test, right? Or maybe at the most 10 problems. You have 40 minutes to do that. Is that enough time to do the work and check your answers?
Yes.
Heck yeah, it is. Okay? So take the time. Follow the steps. Follow the process. Okay? The more you follow the process, okay, the better understanding you have of mathematics. I don't do it to be mean and make you write more, right? I don't want to do that. All right, so your homework is tonight. I want you to do 9 through 13. Right? Is that it?
Yeah.
Okay. All right, your homework tonight is 9 through 13. I'm going to pass back your test right now.